All right, hey guys, welcome back. So today is for review for our exam. So your exam is tomorrow. So the exam just covers chapter 7, so that's all this linear programming stuff. So you guys can expect to have to be able to set up linear programming problems, graph systems of inequalities, find corner points, and overall solve linear programming problems like we've been doing the past couple weeks. So just a couple reminders. There was still the activity and web work 7.3. I think a number of you submitted those already, but just to make sure, those are due tonight at 11:59. So be aware of that. And I've uploaded a practice sheet as well as a bonus web work for the exam as practice for you guys. So the practice sheet is not for credit, it's just extra practice. And the web work is for bonus credit. So do take advantage of that to earn back some web work points. Okay, so anyways, today's review for the exam. And so I want to sort of punt it to you guys and see if you have any questions that you'd like to ask me, or if there's any problems you'd like to see me do or anything like that. I'd be happy to do that. Otherwise, I could try to make up something to talk about. But so let me basically give you guys the floor. Do you guys have any questions that you want to ask or problems that you'd like to see?
Yes, I would like to see how to maximize and minimize in the same equation. And then, let's see. Yeah, basically how to do both maximum, like find how to know if something is a maximum or a minimum in one equation.
Okay, so like if I give you like one function, how to find both its max and its min, is that?
Yeah.
Okay, sure, I could do that. In fact, maybe I'll sort of make up an example here, and we'll go from there. I think I can make up a reasonable one, unless you have a particular one in mind that you'd like to see.
No.
You have a particular one?
Nothing in particular.
No? Okay.
No, nothing in particular.
Okay, cool. So I'll sort of make something up then, and we'll see where this goes. So I'm just going to basically, we'll have an objective function and we'll have some constraints. So it'll be a system of inequalities. And then the question is, how do we find the max and min of the function with those constraints? Because to find the minimum or maximum, we have to have some system of inequalities to be our constraints. Otherwise, we can't really answer the question. So I'll give you an objective function. How about this? 3x minus 2y. Let's do y squared for fun. So here's an objective function, 3x minus 2y squared. And we're going to find, our goal is to find the min and the max. And we're going to have to subject it to constraints for that question to make sense. And so here are our constraints that I'll give you. So how about x is greater than or equal to 0? Y is greater than or equal to 0. These are our typical constraints in a linear programming problem. And then how about y is less than or equal to negative 3x plus, I don't know, how about 8? Keep it sort of, we'll keep it a little simpler just to illustrate the idea of what we're going to do. So this is good. This will review several concepts. So whenever we have this sort of setup, the first thing is graph the constraints. So we need to graph the system of inequalities to see what it looks like and to find our corner points. So we're going to graph this, and then we'll be able to find the min and max from there. So let me put in some tick marks here. Okay. So first of all, the x greater than or equal to 0 and the y greater than or equal to 0, these two together always tell us, as I've said before, these always tell us that my feasible set is going to be in the first quadrant. So these two together indicate that we're going to be in this first quadrant here. So wherever I'm going to shade will be here. So I can kind of ignore the other quadrants and just look in the first quadrant. I know that my shading will end up there. So the only thing I need to do now is figure out, where do I shade with this guy? Where does this go on my graph? And then I'll know that I need to shade to the right of this, above this, and then somewhere in relation to this guy. So this, again, we write down the equation corresponding to it, turning the inequality to equals. I get y equals negative 3x plus 8. This is in slope-intercept form. So, and if it wasn't in slope-intercept form already, I could solve it so that it was, just by getting y by itself. I might recommend doing that. For us, it's already in slope-intercept form. I see I have a slope of negative 3 and a y-intercept of 8. So I'll go up to 8 on the y-axis. and then use the fact that the slope is -3, go to the right by 1, I go down by 3. Right by 1, down by 3. Hopefully I'm counting right there. 1, 2, 3, 1, 2, 3. Okay. Something's off. 1, 2, 3, 4, 5, 6, 7. No. Okay, anyway. Maybe I'm just blind. Okay, this is okay. All right, never mind. Sorry. And then, okay, we will just connect the dots. I think my scale is off is why I'm kind of thrown off here. How about we do this? That looks better. Okay, so my line does something like this. It has a slope of -3 and it has a y-intercept of 8. So where am I going to shade with respect to this? If I choose any point not on the line and test it, maybe 0, 0. Let's plug in 0, 0 into this inequality and see if that's true or false. Because 0, 0 is down here, not on the line. So I can test it. If I plug in 0, 0, I get 0 is less than or equal to 8. That's true. 0, 0 is underneath the line, and I got a true statement when I plugged it into the inequality. So that means that I have to shade underneath the line. So I'm shading to the right of the y-axis, above the x-axis, and underneath the line. So it's this triangle where I'm shading. So this is my feasible set here, is this triangle. Okay, so we have it graphed. And now I just have to ask where are the corner points. So where are the corner points? And here they are. 2 of them are sort of obvious from the drawing and how we set it up. So I know I have the origin 0, 0. That's one of my corner points. Another one is this y-intercept. I know this one too. That's 0, 8, because it's the y-intercept of this line that I graphed. The one that's not so clear immediately is down here, because it's hard to tell where it really should have gone because I drew my graph kind of sloppy because I'm bad at drawing. And so I don't want to be overly confident in where I drew this. So I want to find out for sure where that is. So to do that, we're going to find the intersection of this line and the x-axis. So really, we're just finding the x-intercept of the line. And that line was y equals -3x plus 8. We're just going to find the x-intercept, which means I just set y equal to 0. If you like, it's solving this system of equations. But that just means y is 0. So I plug in y equals 0 into the equation, and I solve for x. And I think we're going to get x is 8/3. So my other corner point is 8/3, 0. Those are my 3 corner points. Okay. So now I've graphed the constraints. I found my corner points. The last thing to do is find the minimum and maximum, which was really getting to the heart of your question, is how to find that. So we have to do all this other stuff to be able to find the minimum and maximum, because the fact is that no matter what the minimum or maximum of this is, if I'm subjecting it to these constraints, then the minimum of the maximum have to occur at a corner point. So if this has a minimum or a maximum, they have to happen at a corner point. And so that's why I need to find the corner points. And now that I've found the corner points, I'm just going to plug them into the function. So we're going to plug in the corner points. Into P. And we're just going to see what we get. So I like to make a little table. So on the left, I have the coordinates of my corner points. And on the right, I'll put the values that I get when I plug them into P. So my corner points, again, were 0, 0, 0, 7, or sorry, 0, 8, right? 0, 8 is the y-intercept of that. And 8/3, 0. Okay. So now over here, I'm just going to write what I get when I plug these coordinates into P. So when I plug 0, 0, 0 for x and 0 for y into P, I get 0 minus 0, which is 0. When I plug in 0, 8, I'll get 0 minus 2 times 8 squared. 8 squared is 64. Minus 2 times 64 is minus 128. So minus 128 is what I get there. And then 8/3, 0, I'll get 3 times 8/3, which is 8, minus 0, so I just get 8. That worked out nicely with that fraction. I didn't plan that, so that's kind of nice that worked. So here are the values I get by plugging in the corner points. I get 0, -128, and 8. And so now to ask about the minimum or the maximum, the minimum is the smallest value that I get. So I just looked for the smallest of these three numbers for the minimum. And the smallest is negative 128. That's less than 0 and it's less than 8. So this is our minimum, because it's the smallest thing I got. And again, the minimum, if it exists, has to be at a corner point. These are the only corner points, so this is the minimum. And then the maximum, of course, is the biggest thing I got, which is 8. So here's our max. And so now I'm done. So in general, this is how we proceed. I have to graph the constraints. I have to find all the corner points, and then I just have to test all the corner points in my function to find out what the biggest or smallest value I get is, depending on what the problem is asking for. Because the minimum and the maximum have to happen at a corner point. There's one thing that's iffy is if this is not, so here this is an example of a bounded, this is a bounded feasible set because it makes a closed shape. In this case, it was a triangle. So it makes a nice finite closed shape. Yeah. And so in that case, I just literally test corner points and I'm done. There will always be a minimum and a maximum in this case. If it were unbounded, I have to be a little more careful. There might not be a minimum or maximum, and I might have to test some extra points, which I think we did this on Tuesday in class. But I'll stop here and now ask if you have further questions.
Thank you for that. So on the exam, do you know if we will have to graph a fraction in this situation, or would it be just like normal values?
So what I would say is you may very well have to deal with fractions, either as a slope or as coordinates of a point like this 8/3. So I would count on maybe having to deal with some fractions. I guess technically you could get fractions anywhere. These could have been fractions. It just depends on the problem. But so I would say, yes, you could get fractions or decimals. But that won't change the overall. The overall method is the same. It'll just change your particular calculations is all. Okay. Any more questions or requests for problems? So, anybody have any more questions?
1 second.
Sure.
Okay, perhaps like on activity 7.3, one of the word problems that also includes graphing, it's 17 and 18, perhaps something like that.
So like something like 17 or 18. Yeah, just let me take a quick look.
Sure.
Okay, so yeah, these are basically, this is basically like solving a full linear programming problem sort of from scratch. And I can certainly do another one of these. At the very least, get it set up and get you started. So the idea here is this goes back to like, it sort of puts the whole chapter together, everything that we've done. And so like back in section 7.1, the goal was just to sort of set these kinds of problems up and not actually solve anything yet, just get used to setting them